Good morning and welcome to Business Math class. We've been discussing some different topics here before class, and we're going to clarify them so that we're all working with the same thoughts. The first problem that I want to talk about is in 5.2, problem number 17. 5.2, problem 17. In the edition of the book that I've got, it's on page 163. That's what page it'll be on your book. If someone were watching these tapes later, those pages might change just a little. On number 17, it asks for the ending inventory value using the weighted average method. If you would go ahead and extend each one of those prices in the Barney's hardware problem, you would discover that Barney purchased a total of $7,575 worth of hammers during the year. He bought a total of 555 hammers during the year. So if we wanted the average price of any one hammer that he purchased during the year, we would take 7,575 and divide it by 555. What we did in class the other day is went ahead and rounded that number to 1365, and then we were multiplying it by the 167 that were left. If you do that, the answer that you get is a little bit different than the answer that's in the back of the book, and that's what several people are saying. I'm off by pennies. This number, this 1365, is actually rounded. The answer that's in the back of the book actually is the 7,575 divided by 555 times 167 without doing any rounding here. We're off by just a teeny tiny bit. Cassandra, does that make sense? Is that the question? Was that the problem that you were having trouble with?
Just on 5.3.
Oh, on 5.3 you're having a rounding trouble.
Yeah.
Okay, we'll do it next then. Several people were asking about this one, which was, this one actually is number 17 on 5.2. The answer that you get here is, what did you get, Patrick?
22.79.32,
No, you had a bigger number.
32 is when you don't round.
That's exactly right. Okay, do 1365 times 167. What do you get? How many? 55, right. If you don't round this number, if you leave it in the unrounded form and take it times 167, you'll get the answer that's in the back of the book. I find both of those acceptable. This one's going to be 55, the other... I'll take either answer, yes. It depends, and it really is a rounding issue. Whether, huh?
The back of the book has 55.
It's the 32 is the not rounded. The back of the book has 55.
22.79.55.
Oh, okay, 55 is in the back? Okay, I misunderstood Patrick. I thought he said you were getting 32, so you were... Oh, because you weren't rounding.
Yeah.
Okay. If what we were doing was rounding, taking it times that, and you're going to get this answer, what Patrick was doing is getting 13.64 some long decimal, taking that times 167, he was getting a smaller number. Either one of those is acceptable. Or I'm happy with either one of those, yes. Does that answer your question, Patrick? And that's the reason it was wrong. Not wrong. That was the reason it was different. It kind of depends on where you round, okay? I think the other thing we'll address before we do anything else, I'm going to give Patrick back his work, is the problem that we discussed at the beginning of class, and I said I would get a hold of Steve Wilson, who's the author of the book, and ask him. Problem number 23 on 5.2, the answer actually is wrong in the back of the book. And someone else had already told him that, and it had already been corrected. The correct answer is 24.16. Fran, I think you were the one that had that question. And he just laughed and said, you know, I don't know where I got that other answer. And that's kind of what happens when you look at how thick this book is and how many problems there are, and he's doing a lot of data entry. I think we're very lucky. Many first edition books have a lot more problems than we've run into. So anyway, that one was 24.16, and that was the answer that you were getting, right?
Yeah.
Yes.
And
Okay.
I eventually worked it out to get his answer, so how he got his answer, but
Okay.
it didn't make any sense based on the method he told
Right,
us
and
to
I
use.
did play with that that evening before I called him because he's got office hours at 8 o'clock in the morning, and I couldn't even, the numbers were quite large. It was like $15 and $16 a hammer, and I knew that wasn't right.
Yeah, it went back to like using the FIFO instead of LIFO.
So he was using the wrong
He was
answer
kinda
coming
using a
in. Yeah.
combination,
So
yeah.
he just said, you know, sorry. And so that's how come we get together a few times a week and go over these things. And that's been corrected for the next edition of the book that's already gone to the publisher. Yeah, just a second. Holly's got a question.
Could you show us how to do number 23?
I will. Kari, is that what you want to know?
Yeah, because it says using the results from
We'll do 20
the data.
Okay.
It used 167 was left. So
Okay,
I'm
let's do
wondering-
number 23. If you notice, we've got A, B, and C exercises. The A exercises should be the most straightforward. Usually the B exercises are sort of word problems. And the C exercises are a little more complex. They kind of stretch your thinking. And this one is a C exercise. So what we've been around Barney's is several years. Okay? And the information in Barney's hardware for 1999 is the B information. And when we do the inventory at Barney's and we get the answer to number 15 at Barney's, the ending value of the inventory using last in, first out is the key number that we need. How much was the ending inventory last in, first out at Barney's in 1999? $2,041. So that's 1999, okay? What happens in problem 23 is the year changes. It becomes year 2000, okay? So Barney's got these hammers left over. How many were there? 167 hammers that the total value is that much last in, first out. Is that making sense? This is left over from 1999. Then Barney makes some more purchases. Barney buys 75 more hammers, and they were $15 a piece in April. Barney buys in October another 95 hammers, and they were $16 a piece. We come down to the end of the year. And we want a year 2000 last in, first out amount. And how many hammers do we have left this year? 192 hammers. So you understand all this stuff up here happened in 1999. These things happened over the next year. The hammers that sold at Barney's, the last ones in were the first ones out. How many total hammers were accumulated at Barney's during the year? It would be the ones that I had in the first 167 plus 75 plus 95 more. Are you with me? How many are left right now? 192. The 192 that are left, Holly, would be all of the ones that were here originally, and I'm doing in red, but it doesn't show on here, all of that 167, which had a value of 241, plus an additional 25 hammers that were purchased here at $15. Do you understand what I'm doing? So, your calculation will be the old hammers from 2 years ago, plus the 25 hammers that cost me $15 a piece. 25 times 15, I've got that written down here someplace, 375. So it's going to be my 2,041 plus the 375 should come up to 2,416. And what we're saying is some of that merchandise that is still in the store, you've been there, you've seen some of those stores where there's dust on the stuff in the back. It's been hanging around for forever. Friends laughing. Yes, that's happened. Yes. I tend to do, I buy computer paper 2 and 3 reams at a time. And, I stack the one on the bottom, and I keep buying new ones and putting them on the top. I bet you that bottom stack of paper has been there for forever. I never go to the bottom and grab that paper. I always, as I put more paper on I have a shelf that I keep all my computer paper on, and I guarantee you that last 50 or 75 sheets has been there since the first computer I ever owned, because I keep stacking new. It's all the same, so it doesn't matter. Hammers are the same way. They're not spoiling because they're 2 years old. They look the same. We don't tend to pull them to the front and put the new hammers to the back. Versus if this was milk or something that had some sort of spoilage, you keep pulling stuff forward and putting the new stuff. But this could very easily happen. Did that answer your question, Holly? What about you, Kari? Okay.
25.15.
Okay, question? I didn't hear the question originally.
Never mind.
Okay. Are there any other? Yeah, Marilyn.
Are you likely to have a question like that on the test?
No.
Okay.
That's sort of to stretch you
Just an exercise.
in seeing if you get the concept. Sometimes if you see a more complicated one, it makes the ones that are straightforward seem more straightforward. No, I'm not going to. I don't like to ask the C-type exercise questions. And they definitely won't be that way on the final. They'll be very straightforward. And it was using that 15's answer. I think it wouldn't have been so frustrating if the answer had been right in the back to begin with for people, too. Great. Anything else on 5.2? 5.3a. Questions on, and I know there's some rounding questions here. Let me clean up my mess just a little bit. People have rounding questions. We've got 1, 3, 17, and 20. And people were saying earlier, we've rounded to the nearest dollar in the back of the book. And for income tax purposes, that's exactly what would happen. I think any of you that have gone someplace and had your income tax filed, you know that, and I was explaining that earlier to Karen. If you made $1,025.37, they're just going to round off that 37 cents. I mean, for income taxes, the government's not requiring us to do that. And the same thing with an asset. An asset that's in the range of, $4,000 or $5,000, we're not going to depreciate it to the nearest penny. The nearest dollar will be fine. And that's what they're doing with your answers in the back. Cassandra, what specific one did you want to talk about? Or did that
I didn't
answer?
have a question on that.
I thought you had a rounding question on 5.3.
Oh, well, I just was off by pennies. But
Oh,
she explained
okay.
it to me.
Okay. Okay, and
Yeah.
it is just rounding by pennies.
Yeah.
Anything else on 5.3? 17, 5.3. Okay. Let me get there.
The right answer.
And that's a good place to start because we really do want to review straight line because we're going to talk about accelerated depreciation today, and that's great. Tyler and Johnson, a law firm, purchased something that cost $75,000. It's office furniture. It will have a scrap value of $8,000 in 7 years. Set up a depreciation schedule. So let me get going here. Let me get it might take me a minute to get everything lined up. We're going to start out by doing year. Then we're going to do this year's depreciation. Then we're going to do accumulated depreciation. And then we're going to do book value. I just was writing BV up there the other day, and someone told me that confused them. So I'll start writing book value. We always begin with year 0, and we always begin by putting the $75,000 right there that we purchased. Okay, I'm going to go ahead and number 1, 2, 3, 4, 5, 6, 7, and I'm going to, now let me see if I can get all this on here. Okay. And I'm also going to come down here and put $8,000 at the very end because, Well, that's too bad. We're going to go on anyway. Because I was going to pick a...
I put 67,000 at the top instead of 75.
Okay, he said, I put 67,000 at the top instead. Good. I want to go through this first step because what I'd really like to do then is talk about double declining, and what my goal was to get some numbers going here at the beginning, refresh our memory about straight line, and bridge over to an accelerated declining. So let's do the right thing here to get going. First of all, we need to know when we're doing straight line, how much total depreciation are we going to take? What is that special number, Keith?
17.
No, well, yeah, no, that's not the number.
Total depreciation.
Total depreciation. How much total depreciation? You had the magic number a minute ago.
$67,000.
$67,000. Good. Over 7 years, this item is going to depreciate a total of $67,000. So when we're doing this year's depreciation, what we're going to do is 1/7 of the $67,000 each year. What's the decimal equivalent of 1/7?
0.142857143.
Kind of long and strange, right? I was telling Christine after class the other day, she says, I like dealing with decimals a whole lot better. So I will show you how to go ahead and store that number. Give me a minute first, however. We can, there's many ways of calculating this, and I want to talk about it, and that storing that is another thing we want to do. We can do 1 divided by 7 equal. We can take that times $67,000. Let's do that one first. Do 1 divided by 7 equal. It won't work if you don't hit equal. What are we coming up with as the depreciation amount? Rounded to the nearest dollar. 9, 5. And we're going to throw away the 43 cents. Isn't the back of the back of the book is always rounding to the nearest dollar? Is that all right? Oh, it's not?
No, that was just when it was finding the annual.
Okay, all right. 9571.43. Okay. And then we're going to use that amount each year, right? The other way we can do this one is take the $67,000 and just divide by 7. Take $67,000, divide by 7. You should get the same number. Okay? If you've got the calculator that we're using for this class, I can show you how to just store that 1 divided by 7 value so that you can just be using it when you want it. You take 1 divided by 7 equal. Okay, and hit the button that says store. Okay, so now it's in the memory of your calculator. You can go away, you can do anything else you want. When you come back, you can take 67,000 times and then hit second. And do you see that there is a mem button there above? You see where the memory button is? Let me grab my calculator. It's above the 0. Okay. When you hit second, now you're going to hit recall, then you're going to hit second mem, and it'll pull that number up.
No, it didn't.
Oh,
Do it
will.
again.
Hold on.
Do it again.
I'm going to do 1 divided by, mine's not on, hold on. 1 divided by 7 equal, and it's a long, crazy number, right? Hit store. So now it's in memory. Are you with that? So we can clear, we can do 56 or any crazy number times. I just picked a number for no particular reason, yes? Now go recall, second. Second says do the green stuff above there, mem, and it'll just pull it right back up. You have one nice memory spot in your calculator. How you store into that spot is put it into STO. It's there. Whatever else you do, you can be going along. And then whenever you want to recall it, you hit recall, second, and this the mem is right above the 0, and it'll pull that number out for later use. We're going to be using that a lot when we do simple interest next time. We're going to be dealing with that memory button. So if you like dealing with memory, that's the button we're going to use on there. Okay. And when we get done, we're going to have exactly the same amount of depreciation each year. Hold on, let me go back out here ways. We know that this 9571.43 is going to be down every column in this year's depreciation, right? And we're going to always take the $75,000, subtract the 9,571.43, and just keep working from book value, taking away that amount, coming down to $8,000. And we're going to have to adjust the last one by a penny because of a rounding. Because that, obviously, 1 divided by 7 is a strange decimal that doesn't come out as neat as 1/4, 1/5. Yeah, it doesn't terminate, doesn't end. It goes on, where those fractions that are like 1/2, 1/4, 1/5 have a terminating decimal, and so it's much like the one we did in class the other day when we had 1/3. It's a repeating decimal, so you have to adjust by a penny or two in the end. Okay. Key in straight line is the number that we multiply is always the total amount to be depreciated. That's a very important number. And we multiply by 1 divided by 7. Or divide by 7, okay? New situation, we're going to lay that one aside, and we're going to come back and get this one started double declining in just a minute. So I'm just going to take this sheet of paper and set it aside. We're going to pick it up in a minute. When you've got double declining, it's like a car. Things don't go down in value all the time. Double declining is more like a car. What happens with the depreciation on a car? You drive off the lot and you lose a lot to begin with. And then you drive and drive and drive. And has anybody bought a car for a couple $1,000s and drove it for a couple years and you can still sell it for a couple $1,000 after that? My dad drove an old truck that he paid like $1,000 for 5 years. It was an old truck that, you know, you had to put a board in the floorboard so you didn't see the road beneath you. But after driving, it was an old truck. It was kind of depreciated to nothing, and then at the end, it wasn't going down hardly anything. So generally, when we're talking about items that depreciate a lot at the beginning, then many times they actually hold that value versus straight line, that it's the same amount every year. Okay. Double declining, double, what does that mean? Times 2, that's right. So if the normal depreciation rate over 4 years is what decimal? 0.25. If I were to double that, what would the depreciation rate be? 0.5, that's right. If the normal depreciation over 5 years is 1/5, what's the decimal? 0.2. Double it. 0.4, that's right. What double declining says is double the depreciation. So you take the decimal, you take the fraction, you come up with a decimal, and then you multiply it by 2.
Do you do that for every year?
Yes, and there's one other difference. I'm going to come back here, and then we're going to go do one. Do you see what we're multiplying by here? The total amount to be depreciated. In double declining, that's not the number that goes in here. The number that goes in here is always the prior year's book value, prior year's book value, prior year's book value. Okay? So let's get started. So there's 2 things that change. We're not using the total amount to be depreciated. We're using prior year's book value, and we double the depreciation rate. Okay? Problem on the handout under double declining balance depreciation. I labeled this one B, and we're going to come down to problem number 1, and we're going to do it together. Does it make sense where we are? Okay. A machine has an estimated life of 5 years. It costs $2,500, has a scrap value of $125. Prepare a double declining balance depreciation schedule for the machine over the whole life of the machine. Is that all right? So here's some things we know before we get going on our chart. We know that it costs $2,500. We're going to keep it for 5 years, and at the end, it's going to be $125 scrap value. Okay? All right, so here we go. Year, same topics. This year's depreciation. Write in pencil if you're ahead of me. Cube depreciation. Book value. We also know that in year 0, when we purchased it, we paid $2,500. It's going to last for 5 years. And we know the scrap at the end is $125. So it starts out looking exactly like a straight line schedule. 5 years. If it were straight line, what would be the rate of depreciation? 1/5, which is, what's the decimal for that? 0.2. This is double declining. So instead of 0.2, we're going to take that times 2 and get 0.4. So 0.4. Now, the major difference besides that we've doubled it is we do not consider scrap value at the very beginning. The number that we multiply by is always prior year's book value, not total to be depreciated. Prior book value. So, what's the prior year's book value? $2,500. What's then the total amount to be depreciated during the first year?
Don't you do 2,500?
Times
Oh,
0.4.
divided.
Oh, no, we're multiplying. So we're going to depreciate at $1,000 the first year. So if we have an item that we bought for $2,500, we depreciate at $1,000 the first year. The accumulated depreciation during the first year is $1,000, and the new book value is $1,500. Is everyone there? Okay. I took the $1,000 that I'm depreciating it off of the $2,500. So last year it was worth, when I bought it, Cassandra, when I bought it, it was worth $2,500. It went down $1,000. At the end of the first year, it was worth $1,500. Okay? Year 2. We continue to use exactly the same depreciation rate. So this continues to be 0.4. The key here is book value of the prior year. What's the book value of the prior year? $1,500. How much are we going to depreciate it in the second year? $600. When we take the test, I'd really like to see charts, and what I'd really like to see is these numbers. You know, do your calculations right on your sheet. Make your spots big enough that you can put what you're multiplying by in there. Do you understand what I'm saying? Show me your work. Okay, so now the total accumulated depreciation is $1,600. I've got last year's book value. I've depreciated $600. What's the book value at the end of year 2? No. You did it in your head. And it's maybe not. Okay, who's got a thought about what the next calculation is? We are always going to do 0.4.
360.
And what are we going to do 0.4 times?
900.
900, that's right. Someone said 360. Okay, think about if this were something that was getting more depreciation at the beginning, less depreciation at the end. Is that happening here? Sure, it depreciated $1,000 the first year, less than $1,000 by a bunch, $600 the next year, then $360. So each year that you own it, it's going down less in value. Okay, so then we've got $1,960 would be the total accumulated depreciation. $40 is the new book value. All right, next calculation. 0.4 times 540, is that making sense? Is 216. Do you see the value is going down less each year because depreciation is less each year? Total depreciation at that point is 2176. We've got 324. Last year, we absolutely and positively must depreciate down to $125. So we just need to adjust this last year. If you took 0.4 times 324, 0.4 times 324, you would not have enough depreciation. So what we're going to do is just adjust and take $199 worth of depreciation that final year, because I need these two numbers to add together to be the total value of $2,500 that I paid for it. Cassandra. Because that's what it takes to depreciate from 324 down to here.
Are you gonna have to do that every time on the last year? Make that adjustment?
And sometimes in a year before that.
Okay.
So you're going to have to on these double declining. Since these aren't an exact decimal, we're going to be. I knew when I got started the total amount to be depreciated was $23.75. I knew my scrap was $125. I have to adjust in that last year to make this happen. Okay? Turn to the top of the next page once you've got that and get started on the schedule by yourself. I will get you going. I will tell you it's a tricky one. You're going to run into surprises. Okay, that's what we're going to do together. We are preparing a double declining 4-year value. So what would the fraction be?
1.5.
Well, the fraction would be 1/4. The decimal rate would then be 0.25 if it was straight line. It's not straight line, it's double. So what's the correct answer, Josh? He was way ahead of me. 0.5, good. See if you can get this one started. And you're going to find surprises at the end. I'll get the first one up. I'm just going to let you work for a while. Keep checking your answers. If you've got questions, and you should by the time you get down to about the 3rd year, we'll talk about them. Has everyone got $12,500 as the book value at the end of the 1st year? Okay, $12,500. Okay. I told you there's going to be surprises in year 3. Watch for surprises in year 3. So we don't want to do that. So we're going to be doing some adjusting. We discovered that in straight line it was the same every year. We did straight line first because it is the easiest. We're doing double declining second because it's harder. And you have to kind of have your head screwed on right to sort of see what's happening here. Is everyone to year 3 by now? Look, let everybody work just a few minutes longer. End of year to book value of $6,250. Are we there? Yeah? Okay. Third year. We've got 0.5 times 6250, and that would give us a total amount of depreciation of $31.25. If we did that, what would happen? It'd be too much. Good. So what we do is say, that's too much, let's adjust. The total amount of depreciation that I can take that year is $22.50. That would give us the maximum depreciation of $21,000 during the third year. So we take absolutely no depreciation during the fourth year.
But on the third year, it's 2,000.
Yes, you take whatever it takes to adjust to get it to scrap. We'd be doing no amount of depreciation whatsoever in that final year. We've taken all the depreciation ahead of time. Cassandra, yes. Okay, it originally cost me $25,000. The scrap value is $4,000. The difference between those is the total amount that I needed to depreciate that item, which is $21,000, over the entire time I'm taking depreciation. This first year's accumulated depreciation is just the depreciation for the first year. The second year, I take the accumulated depreciation from year one and add $6,250 to it to get. Do you understand where the $18,750 came from? Okay. The next year I take the $18,750 and I'm going to add the $2,250 to it to get this. We are actually not using this $31.25. It's too much. So the real number that I'm using is $22.50. You can't go below scrap value. I looked at where I was here at 6250 and where I was heading to 4,000 and said the most depreciation that I can take from 6,250 to 4,000 is 22. I keep saying 1,000. It's 2,250. So I just adjust in the third year and say that maxes me out on all my depreciation. So I throw this number 3,125 away. It's too big. And then in the last year, no depreciation. Accumulated depreciation remains the same. Okay, Marilyn.
Yeah, so when we started out with straight line and we subtracted scrap value from full value and we started with that in year one, and that was our number, that can subtract scrap value from full value, and that's going to end up being our accumulated depreciation right off the bat. We know that we have to come down to that number.
Absolutely. And quite honestly, Marilyn, that is also the case in straight line. When you do that subtraction, that number needs to end up being in your final year under accumulated depreciation. Very good point. And that's exactly what you should be able to do. Always these two numbers should add to the book value from the original year. Okay? The homework problems that you should be able to do when you go home tonight then would be 9, 12, 18, and 21. I want to take a minute then to sort of pull some things together and go back to number 17. This was the one Keith asked about. Let me get this one on the, I'm going the wrong direction. This is number 17. It's straight line. This is 75,000, 8,000. Keith asked us about it. The magic number in here is $67,000. We're multiplying by 1/7. Number 17. This is straight line. We're doing in number 18 the exact same problem, double declining. I want to talk about what two things change. And Marilyn was right. We can go ahead and put 67,000 right in here, no matter which method we're using. And again, Marilyn, these two, accumulated and book value, should always add up to the original book value to check your work every time. Okay. The main difference, if I was setting up 18 versus 17, this is double declining, is I would not be using 1 divided by 7. What number would I be using? 1 divided by 7 equal, and then times 2. So it'd be 2 divided by 7. The reason I'm telling you that is that might be a number you want to store in your calculator, because you're going to use that number each of these times. But what's going to change, what is totally different in double declining, is we never use this $6,700 up here. In our very first year of double declining, the first calculation would be 2 divided by 7 equal times book value, $75,000. Those are the two differences. This number is double. This number changes, and it's always book value from the prior year. So if this were a double declining calculation instead, the first year would be 2 divided by 7. Okay? Does that make sense? Double the rate. Don't use total amount to be depreciated. Instead, use prior year's book value. So this would be the calculation for problem 17. This would be the same calculation, same year, problem number 18. You should always see in double declining greater values in the depreciation amount in the early years, smaller values in later years. Straight line says same amount of depreciation every single year. You're going to have to watch for adjustments when you do double declining. Marilyn's got a question.
On number 12 on that homework, when it says 200%,
Hold on,
is that just,
that means double declining.
that just is?
Yeah, and I was going to answer another question about that in case somebody was assigning some different homework problems for someone that was watching this tape. Some of these call it, instead of double declining, 200%. That means the same. Some of these homework problems would say 150%. Instead of multiplying by 2, you would multiply by 1.5, yes. So if you had a business and then we were preparing a 150% depreciation schedule instead of a 200, you would, in this particular case, if this was a 150% depreciation schedule, do 1 divided by 7 equal, and then you take that times 1.5. I'd store that in my calculator. That would be the decimal that you would use. So in 200%, the rate is doubled. In 150%, the rate is taken times 1.5. Okay? And there are problems in here. I haven't happened to have assigned those, but you could do them just as easily. When you get that rate for 150%, you just store it in your calculator and use it throughout the time.
On 12.
Mm-hmm.
I don't think she just asked this. You get like a decimal 0.1 repeating, and then you multiply that by 2.
By 2, so you're going to get 0.2 repeating. Store it in your calculator.
Oh, okay.
And you've got a different calculator, so I'll show you how to store yours.
I can just leave it on the screen and multiply that times.
I thought you just moved the
Yes, you
decimal
can,
for 9
but
years.
you
Is that
might,
okay?
over a 7 or 8 or 9 year period, get tired of re-entering that.
Re-entering
So if
points
you
in,
want to store the decimal, I'll help you do that in your calculator. And if I don't get it straight, the Math Resource Center will help you get that stored. I kind of, instead of re-entering that over and over and over, would prefer to stick it in my calculator. I don't and just recall it every time that I'm going to use it, because in this double declining, we can't make one calculation. We're going to have to use that decimal down, in that particular case, for 8 or 9 or 10 years. One more thing, and then we'll be done today, is that it's very common for things to be depreciated, large pieces of equipment, over 20 or 30 or 40 years. I mean, like an elevator or something is going to last more than 4 or 5 years. We're using small numbers. Guess why? I don't want want you to make a 30-year depreciation schedule. It would be long and lengthy and ugly, but you would use the same techniques if this was a 10-year depreciation or a 25 or a 15-year depreciation schedule. It would just be longer. So, of course, on the test, I'm just going to ask you to either do the first few years of a large depreciation one, or I'm going to give you numbers like 4 or 5, less than 10 years. Yes.
What I want, on number 20, I don't need to do, I worked it. The thing I was wondering is, when it depreciates down to 0, your numbers are, book value are just catty cornered. If you just actually reverse the order of the numbers, is that always going to be the case when it scrap value is 0? Will I always just save myself some time and just write the numbers backwards?
Ooh, I'm going to have to look at that. Tell me what numbers are backwards.
Well, they're not backwards. It's just that on number 20.
Accumulated and book value switch.
Yeah, like the
21.
first number is 28.5, but on book value, the last number is 28.5.
And that's because it's 5 years, so it's sort of symmetrical.
Yeah, it is.
It is,
It
right.
just reverses order. But I wondered if that was because it came down to a 0 balance.
Yes, it is.
I won't have to work all that out. I could just
If
reverse
it's
my
going to come
order.
down to 0, you're seeing a pattern. I always hate to answer absolutely yes, but that really is what happens in general. Okay, we're going to let you go. You've asked lots of good questions today. Wait a minute, she hasn't got the tape off. Hold on. Let's let her go to black, and we will come back and do units of production, another depreciation type on our class next time. Give us a minute to...